Today, I'll show you how to make your first 3D hologram render using Looking Glass Portrait. Anyways, what is Looking Glass? Looking Glass is an exciting display technology that brings your digital creations to life with stunning 3D holograms. Unlike regular 2D screens, it adds depth and dimension, making your work feel almost touchable. What sets Looking Glass apart is its advanced light field technology, which projects multiple views of your 3D image at once. The result is a vivid, realistic hologram that looks like it's floating right in front of you. But it's not just for show. Looking Glass has practical uses in design, gaming, medical imaging, education, and more. With this tool, you can create and showcase your 3D models, animations, and visualizations in a way that's more immersive and engaging. Whether you're an artist, a developer, or just a tech enthusiast, mastering Looking Glass will elevate your projects to a whole new level. That being said, let's get everything set up and get started. All right, so in this part of the video, I wanted to go over on how to actually use the Looking Glass in Blender. For this tutorial, I'm not going to be using the latest version of Blender because that one still needs to be updated to be compatible with the Looking Glass. So for this video, we're going to be working with Blender version 3.6. This is a long-term support version, so this was a very stable version of Blender that a lot of people are probably using. And to download it, you just go to blender.org/download/releases/3-6. I'll put that down in the video description. If Looking Glass does update their plugin by the time the video is released, then you could use a later version of Blender. Then another thing you need is that add-on that we were talking about. It's on lookingglassfactory.com/blender add-on. I'll also have that linked in the description. You just go to the page, click here, and then you can download it from GitHub. The plugin is called Alice LG. So let's open Blender. I already have it installed, so I should have it there, no problem. If you go into Edit Preferences, Add-ons, and look up Alice LG, I already have it installed. But if you don't, you just go into the place you have it downloaded, select it, and then click Install Add-on, and then it should pop up. Make sure it's enabled. And then the one more thing that you will need is you will need Looking Glass Bridge so that your computer can communicate with the Looking Glass. So once it's connected through USB-C as well as the HDMI port, then it will be able to communicate correctly with the software and the plugin. So make sure to download this as well. It's available for Windows, Mac, both M1 and Intel Macs, as well as Linux. And one more thing I do want to talk about is this website called Looking Glass Blocks. It's blocks.glass. And here you can see all of the community-made Looking Glass blocks. And this is a really cool way of just getting inspiration and seeing what kind of stuff works well with the Looking Glass. And I like to come here and just see what kind of stuff is created, just to spark my curiosity and imagination. All right, so I'm assuming you have Blender installed, you have the add-on working properly, and everything is currently set. For this tutorial, I'm going to be making this animation in Eevee because with this current version of Looking Glass, there are some issues with cycles for some reason. You can still render in cycles, but previewing it before doing the final render, there are some issues. So just to make things simple, I'm going to be doing this tutorial completely in Eevee. For this Looking Glass animation, I want to start off with the most important thing that you need to keep in mind when making animations or stills for the Looking Glass, and that is the camera, its position, and also the limitations, because you have an end clip point as well as a start clip point, and anything outside of that won't be visible on the Looking Glass. So I'm going to start with some placeholder objects. I'm gonna add a Suzanne, and for now, my default file in Blender, I always start with the world shader set to black, so nothing was showing in terms of color. So brought that back up, and now we can see the objects. All right, so from here, we're gonna add the camera, and then place it in the right position. And my apologies, I don't have the screencast keys being shown, but all I'm doing is simple translations, you press the G key to move stuff around, and you press X, Y, and Z to move it along its respective axes, R to rotate. You can also do the individual axes with X, Y, and Z. Those are pretty much the only hotkeys that I'm going to be using. Also scale for S. But other than that, I'm not going to be going too crazy with hotkeys for this tutorial. And right off the bat, if you press the side N button, you open the side panel and we go into Looking Glass. And this is the interface for the Looking Glass plugin. Right off the bat, you want to select the camera that you're using for the Looking Glass. So I just did that, and you can see that we have some kind of changes to the camera that you don't normally see inside Blender. And here are the 3 parameters that you're working with: clip start, clip end, and also focal plane. And these are the 3 sliders you're going to be working with. And this will determine how the focus as well as the bounds of your final animation. So focal length does change this, so you do want to keep that in mind. You can see that having wider allows you to capture more of the area. I mean, that's pretty typical of wider focal lengths. But when you're tighter, you are not able to capture as much of the space around you. So what focal length you use is determined by how large of an area you want to capture and be seen inside the Looking Glass. So I'm going to stick with a focal length of 35. And with these bounds, I want to make sure that it covers the entirety of the scene. So this is right about where it starts, and where it ends is right there. So I just moved the clip end to there. And then for the focal plane, this one's very important because with the Looking Glass, there is this forced depth of field effect. I'm pretty sure it just has to do with the way light field displays work. You have a shallow depth of field that you cannot turn off really. So what you want this focal plane to do is as if you're taking a picture with a camera that has a very shallow depth of field. You want this focal plane to be exactly where you want clear focus to be. And for this particular scene, which we are going to modify later, I'm just using this one as an example. You're going to want the focal plane to be right where the eyes are. That's typically what's done in photography, is that you have the focal plane set to the closest eye, the eye that's closest to the camera. But because we have both eyes the same distance, we're just going to keep it there. And then if we hop into the actual Looking Glass and go into viewport shading, right now it's not too flattering, but I'm gonna put in a random HDRI. Not going to use this for the final animation, so not too necessary for you guys to follow along with this particular part. And from here, I'm just gonna put a new shader and make all of them have the same shader. So we have a scene that looks a little bit better and more digestible. But once again, this is just demonstration. I'm going to change this in a bit, but we're in rendered view right now. And if you go up to the Looking Glass, you can see the different options we have. This tab up here is where you enable the previews, and you can see that it has already updated. If you shift the Looking Glass from left to right, you can see that we have a lot of parallax going on. And this is what you want when you're doing Looking Glass scenes, is you want a lot of stuff in the foreground as well as the background in order to sell that 3D effect. Because if you have everything just on a flat plane, then it really won't work too well. And for previews, you can see that the Blender interface, like if you have an object selected, will show in the preview render. So if you press Shift Z and Alt all at the same time, it turns off the overlays so you can get a clear render. If I press a refresh, you can see now we get a clean look and we get that really nice parallax effect. If we zoom in, you can see that that parallax effect is very convincing, and you really get a lot of it when you know how to position the specific things in the scene. Now, one more thing I wanted to bring to your attention is this view resolution right here. By default, it's set to 48, but if you bring the views up to 108, it will take longer, but you do get a higher fidelity parallax effect. So if you do have the resources for rendering at this higher fidelity, then maybe it might be something that you'd be interested in. That's enough demonstration. Let's get into the actual animation. So I'm just gonna select the camera, Control I to select everything but the camera. That was an invert selection, X to delete. And we're gonna start with a fresh scene. So from here, I'm gonna go back to my plane and I'm gonna hide the camera just for now. And we're gonna start creating a little point cloud thing in geometry nodes. And these point clouds, unlike the typical point cloud stuff I do where it is from photo scans, this is just going to be points created in geometry nodes. So I wanna start with a big point in the center, and because we're not using this actual plane, we can delete the group input. I'm gonna rename this object scene because we're just gonna keep everything in this one network, and also name it scene up here. And let's start with a point. So just search for the points node and plug it right in, and we have our first point. I'm gonna keep the radius at 0.1. And the one limitation with Eevee in this current version, I've seen that in the beta version of Eevee 4.1 with Eevee Next, it does support point clouds, but we're not using that version yet. So we're gonna have to stick with this workaround, which is using instanced geometry, real geometry. It does take a bit more computing power, and that's what I really like about cycles, because you can see that you get these perfect spheres, but with Eevee, we're gonna have to use real geometry. It does not show in Eevee, as you can see. So from here, we get an instance on points node, plug that in, points connected to geometry, and then the instance will be an icosphere set to a subdivision of 2. And let's keep it actually at 3, and then get a set shade smooth node. That way it is set to shade smooth. Also, if you want to search for any node, you just press Shift A. That is the hotkey for that. For these points, every single point in this scene, I'm gonna keep the same material. So let's just bring in the material right now. And I'm gonna make it that same material that we used in the demonstration, which is this. I'll rename it to metal, and it automatically updates in the node network in geometry nodes. And to follow along with me, you just want the metallic set to 1, and the roughness, I'll actually keep at 0.3. And I'm just gonna hop back into solid view, and I'm gonna take out the HDRI because we won't use that in the final animation. I don't want any lighting from the world. We're gonna be adding our own lights. And when I render these points, I like to light them by the sides and also the back, and sometimes having a light from the front, and I like to do that with area lights. So let's just set up the area lights. Rotate by the y-axis 90, but negative. Okay, so we have that first light, and I'm gonna scale it on the z-axis. And you can see that we already get a nice side highlight, and I'm gonna duplicate that and move it to the opposite side. Rotate that on the y-axis by 180. So now we get just a nice rim lighting. And then from here, I'm gonna take these two lights, duplicate by pressing Shift D, and then escape, rotate for R, and then Y. And now we have this. I'm gonna scale it up Z, and then scale X. So what I'm gonna have here is lights on all 4 sides. I'm also gonna scale these up a little bit too. And from here, I'm gonna select the 2 lights on the side, press Alt, and increase the power to 100. So Blender crashed, so I had to redo the lighting. I know, how embarrassing, had to redo this bit. The right side is green. The right side is red with 100 watts. Left is also 100 watts set to green. And then top and bottom are 50 watts set to white. And I put a light behind the point that is set to 100 and it's blue. So from here, I want to go on and save. Make sure to save your work. We can preview this. Just press the preview button and yes, now it's showing on the looking glass again. You can see we have that 1 point. You really don't get too much of parallax because we got to add more points. So the setup I want to do is we go into the geometry nodes, workspace, and from here we're going to add the following nodes. And just one more thing is that I set the scale of this point to 0.5. I'm pretty sure the default for instance on points is scale is 1, so just keep that in mind. And also the icosphere subdivisions I set to 4. And from here what I'm going to do is I'm going to add a cone, and instead of previewing this cone, I'm just going to plug it in straight into the output so we can see what we're working with. And I've already tried this before, so I'm just going to input the values that I found work best. Vertices 48. Side segments 12, radius top is 0.5, radius bottom is 1.41, and depth is okay. So I'm gonna add a transform geometry, and I believe the rotation, if you set it to minus, no, that was the wrong one. If you set the X to minus 90, then we have it facing this way, which is great. I'm also gonna bring the Y to -1. And then I'm gonna also slightly adjust the clipping point. Clip start, we move closer to the camera. And then the clip end we can bring up. And from here, it doesn't seem too obvious, but we can convert this into points. You can see that we have a mesh, and each point in this mesh, each vertice will be turned into a point. And then we're gonna have like a little bit of an abstract animation. So we take another instance on points, and then we grab this icosphere that we are going to instance, and we also use it for this. So we grab it here, and you can see that we have something right now. It doesn't look quite right. That's because we need to bring the scale down. And you can see that we have a lot of cool points. But the one thing here, and this is a bit of an introduction to vector math, is that I want the scale of the points at the front to be larger and the scale of the points all the way at the back to be smaller, because you can see that it looks very densely packed here in the center. But as you go out, there's a lot more space for the points to breathe. So I just want it a bit more proportional. And the way to do that is with a position node, because you can get the gradient through a position. If you get a separate XYZ, and I'm gonna show you the preview very quickly. If you get the Y-axis, which is what we're gonna be working with, and I wanna modify this gradient with a map range, place it right there. And you can actually use the Blender grid to help you out when it comes to these geometry nodes. If you go in the Y grid, you can see Y from left to right. You can see this line right here is 1, and that's -1. It's a little bit hard to see from here, but if I just annotate here, this is -1, this is 1. This is just like one part of the grid, and it's relative to the position coordinates, and you can use that in geometry nodes. So from min, from -1, because that's the end clipping point, to 1, which is the start clipping point, we can manipulate the points that way. So if we just plug it into scale, you can already see that we got something going. My camera ran out of battery, so we'll go without my face for a little bit. But the 2 min will set to 0.08, and then the 2 max will set to 0.04. And then in theory, yes, it looks great. So you can see that we get a bit more breathing room for all these points, and it looks nice. Then from there, if I join the geometry, bring it together, and go hop into rendered view, you can See, we got a nice little point cloud scene going on. If I hop back into layout, make sure to save this time, hop into rendered view, press Shift Z Alt to turn off the overlays. Then we can test out a little preview and see how that looks on the looking glass. Right now it's rendering, so it took a little bit, but I'm gonna move the mouse and you can see we get a nice parallaxing scene. Last thing I want to do is make this an animation and render it. And from this point, you could feel free to play with any of these values. You can play with the amount of vertices in the cone and you can see it dynamically changes. You could change it to different looks and you can have it automatically update in the looking glass, but I'm not going to do that because that will use a lot of resources. And then the last thing, I just want these outer cone points to move. So in order to make anything move inside geometry nodes, at least my favorite node is the set position node. Grab that. And we're going to move it with a wave texture. And the way we're going to move these points is by rotating it. So we got to get a vector rotate. I understand that this might be a little bit intimidating for someone who first starts using nodes in Blender, but just bear with me. Hopefully it will make sense. Vector, we are manipulating the position of the point, so we would be using the position. The center will remain untouched, and that type we will set to Euler. And if I just plug it in as it is right now, you can see nothing changes, and that's good. All right, my face is back. The camera stopped overheating. Anyway, so just like that, now we can rotate inside geometry nodes, and we are manipulating the position, and you can see that the center is exactly what it is. If you move the center around, then it will move the whole thing. It's like kind of like a pivot point. And then what we want to do is we just want to manipulate the Y. And to have it rotate like this would be boring. We want the points to rotate based on where they are on the Y-axis. So in order to manipulate the Y-axis, we only want to be touching the Y rotation. So we get to combine X, Y, Z, and then we can only manipulate the Y from that way. I will get a wave texture set to Y and plug in the color into Y. And then from there, you can see something changed. And if we manipulate the scale, you can see that we quite are getting something closer to the final thing. The one limitation of this wave texture compared to the noise texture is that you don't have a 4D dimension. With the noise texture, you can animate it over time. The wave texture, you can't really do that. The only thing that you can do is push the wave around, and that's done with another vector node, vector math. So if you grab the position, because that is what we're working with the position of the points. You get a vector math and plug it into the top socket. Don't want to overcomplicate this, but what we're doing with these three nodes in particular is the add is just allowing you to move the wave. So let me just demonstrate that. Get this instance on points, and we want to, yeah, here's a good side view. And let's set the scale to 0.1. And also now from here, you can see that if you move the Y-axis of the math, we are pushing the wave left to right. And the X and Z does nothing because we are only working on the Y-axis. So this is a little bit simpler for you guys, but hopefully this still does make sense. So we're just moving a wave, and this wave, you could see all these values which are stored as just a float, which is just a black and white color value in a sense. These are the values in which how much it's being rotated. So if you're a person that learns better visually, I can just show you what this setup does, and you can see that the points are rotating based on that wave value that we had. Let me show it to you again. So you have these values. These are the core values that are telling the amount that the rotation should be. And by using this vector math, then it's feeding into a vector rotate, and that's affecting the position of it. Hopefully that makes sense. So for a beginner, I feel like this could be a bit of a complicated setup if you're first getting into geometry nodes. So let's go through just this patch of nodes one by one. We're getting the position field, and we're adding something to it. What this does is it allows us to translate the wave texture. As we move through the y-axis, it's pushing the wave forward or back depending on how you keyframe it. Now, because we only want to manipulate the y rotation, we get a combine XYZ, and we can plug it into this rotation socket, because if we didn't do that, we would be manipulating all the rotations. And this is a nice look, but this is not exactly what we're going for. Plug that back in, and with the vector rotate, the vector that we are manipulating once again is the position field. So we plug that into vector, and vector into position, because we're affecting the position. When you're working with noise textures, it's a little bit different. You can work with offset, but once again, don't want to confuse you too much. And just with a simple node setup like this, 1, 2, 3, 4, 5, 6, 7, we are doing some sort of dynamic animation. And the last thing you need to do is keyframe this. So I already have the animation set to 150 frames. Having a background in mathematics certainly does help when you're getting into more advanced geometry nodes animations. But it's funny coming from a person that did fail calculus twice, and I ended up going into this type of math anyway, and just being forced to learn it once again. But pretty much a full cycle of this is half of pi. So we just need to keyframe by pressing I on the node and going to 150, and we're just gonna change the y value, and we can add pi divided by 2, which is 1.57108. And if we click on the node, just press I again to insert the keyframe. And the only way to get the keyframes of the node to show is by either clicking on it, or if you go here, view only keyframes on selected channels, you get every single keyframe in the project file if you can't find it. But to find that specific keyframe, just click on the node. Then I want to select both keyframes and set the interpretation to linear. And if we go into the viewport, you can see that we get a seamless loop. Matter of fact, that was a lie. To get a full revolution actually is pi. I'm gonna fix that, set it to linear once again. And if we go into rendered view, you can see now we get this nice animation. So we have a 150 frame animation, and this is ready to render for the looking glass. The one thing that's special about these looking glass animations is the fact that it's rendering a quilt, I'm pretty sure what it's called. And it's just a bunch of tiles in a single frame. So instead of rendering actually one frame, it's rendering the same frame 48 times from slightly different positions. And if you have a tiling or view resolution of higher, of 108 views, it'd be rendering that same thing 108 times. So with looking glass animations, it is rendering each specific view at a smaller resolution, but just keep that in mind when you're doing renders. It might take way longer than a typical Blender render because you have to render all the individual views out. So from here, we're ready to render. So I'm going to get a render folder, probably gonna blur this out, as you could just put it in your own place that you want. But yeah, I have a folder called project assets. So I'm gonna name this looking glass. And there we go. I'm not gonna have any render layers. And one more thing that I also did in color management, I set the look to very high contrast just to make it pop more. So now all I need to do is do the final render. And to do that, so instead of rendering how you normally do in Blender, where you go and up in this tab and press F12 or Control F12 to render animations. You do it in this tab right here, render animation quilt. And you'll see now it's going through all the different views, and this is what I'm talking about. It's going left through right to get the different angles. And you can see that it's rendering at a lower resolution, but it has to render 48 of these. So that's going to take quite some time. So I just finished the first frame of rendering, and you can see how the quilt looks like. And this is going to be an image sequence to use in the looking glass. You can manipulate this in however way you want. You can do color adjustments. Some stuff won't work too well if you're using glow. Each of the edges can't really overlap into each other. It might cause some artifacts, but you're going to have to render each one of these for each frame. The plugin takes care of it automatically. So it finished rendering, and some of you may be assuming that it took overnight to render because I'm wearing different clothes, but I'm just recording this part on a different day. For you, it would take maybe an hour or two for these 150 frames to render. And one thing that I want to point out is that sometimes Blender will crash when you're rendering these looking glass animations, but there will be an option here to continue to render right where you left off from if that happens. So you just press the continue button and it will resume. Now from here, we have the finished quilt sequence. So the one thing that you want to do before you bring in this image sequence into Looking Glass Studio is you just want to convert this image sequence into a video. So I'm going to do that in After Effects. And you can bring all the frames in like this because sometimes the image sequence won't be created automatically. You just take all the images, drag and drop it here, and we make a single composition with a still duration of the amount of frames that we rendered out. And once we do that, we could just press Alt and then right bracket to make them all one frame long. Right click, keyframe assistance, sequence layers, and then it should be playing just fine. Boom. So it's going through all the frames as they should. Export, add to render queue. And this will be Looking Glass Quilt Render Final. I'm going to name this Quilt Render Final and save it in the same place. And then also make the bitrate much higher. I'm going to make it about 200 megabits per second just so that we could get no loss of quality, and hit render, let it do its thing. So you just want to take the finished render, drag and drop it into Looking Glass, and what it is a quilt photo and video. Hit OK. And then the last thing we want to do to make sure that it's being rendered correctly is that we have to make sure the columns and rows are correct. We have 8 columns and 6 rows. And just like that, it started working properly. And you can see now we have the finished Looking Glass animation. Looks great. Then you can hit the sync playlist button so that all of the files that you have for Looking Glass stay on the Looking Glass. You don't need to have it plugged into your computer for it to run. And just like that, we have our finished Looking Glass animation. I'm gonna pick up my phone, and you can see that you can get different looks based on how you look at it, what angle it is, and this is super cool. And that's the end of this tutorial. If you're particularly interested about the point clouds, I have a full masterclass that goes over the process of how to create these point clouds from start to finish. I'll have that linked below. If you want to grab a looking glass for yourself, I'll have that also linked below. So go support Looking Glass. Go check out my point cloud course, and thank you for making it to the end of the video. If you want more videos like these, I'm making some Blender stuff on YouTube, and then on top of that, I'm gonna be making content that is particularly oriented towards artists and how to grow as an artist. So stay tuned for that one as well, and I'll see you in the next one.